Hi, my name is Danielle, and I did my project on reduced neuroinflammation and improved functional recovery after traumatic brain injury by prophylactic diet supplementation in mice. So, what is traumatic brain injury? Traumatic brain injury, according to the article, is the consequence of an experimental impact that triggers pathways contributing to pathological changes in the brain, leading to alterations in the brain function. So, a TBI can happen when a hit or blow causes the brain to hit the skull suddenly, and this commonly occurs in car accidents, falls, and athletic injuries, or any incident where trauma is caused to the head. There are currently no medications that can be used for TBI or that are approved, but multiple studies have shown that diet can impact and help with the prevention of and treatment of brain syndromes. Grand fusion diets are a combination of fruits and vegetables, and these have been proven to have an impact on inflammatory markers that can cause stroke. So in this study, the purpose was to determine if prophylactic diets such as a GF diet has an effect on the outcome caused by traumatic brain injury. So mice were fed diets enriched in fruits and vegetables for 2 months prior to this study and then subjected to a TBI. So the objective was to determine if the presence of these photochemicals can limit the extent of the injury. So for this, a craniotomy was performed. They removed a portion of the skull cap and then did the procedure using a controlled cortical impact to cause the trauma. So 6 mice weighing 22 to 25 grams had free access to food and water before the experiment. 100 male mice were then kept on a 12-hour light and dark cycle at the age of 10 to 12 weeks in the beginning of the experiment. They were randomly assigned groups before they endured the TBI, and they were fed for 2 months either a normal diet or a normal diet with 2% supplementation. There were 3 groups: a veggie blend, a normal fruit blend, and a vegetable blend. There were 4 methods that were used: a rotor rod assay, wire hanging test, grid walking on foot fault test, and a cylinder test with a Morse water maze. So for the first test, 2 trials were done originally with 16 revolutions per minute for 60 seconds, 3 trials then afterwards at accelerating speeds. The falls were recorded from the cylinder, and this was the baseline latency. 3 daily trials were done following this at 15 minutes at a time. The wire hanging test was just a stainless steel bar that was used elevated above the surface where they would hang from, and they would score for how long they were up on the wire. Western blot test was used to check the protein levels, and this happened 24 hours after the sham or TBI occurred. The levels are known to be raised during this. The ELISA test was used to measure the levels of tumor necrosis factor, and brain lesion volume analysis was used on the last day of testing, where they removed the brains and cut them into every 4th section, which was processed. Grid walking foot fault tests, they were placed on a floor and they were videotaped, steps were counted, and the number of foot fault errors was recorded. The cylinder test and the Morse water maze test was done. 20 movements were recorded during the 10-minute test, and the final score was calculated based on the equation down below. So the mice on the GF diet showed less neuromotor dysfunction and recovered faster than the TBI mice. The mice in the sham control group remained pretty much the same, as you can see from the graph over here. The latency to falls was a much lower number for the ones that it had occurred in with no supplementation in their diet. GF diets were able to reduce cognitive deficits. This was determined by the water maze test. The swimming velocities were relatively the same, but the amount of time that they stayed on the target quadrant was longer in the ones who had the supplemented diet, which this was proven that the ones who endured the normal TBI with no supplementation in their diet had more memory deficits. All mice had improved between 22 to 26 days post-injury, but it was at a much slower rate than the ones who had the supplementation. GF diets reduced sensory motor deficits as well. You could tell this by the grid walking and foot fault test. The total number of steps was much higher in the ones with the supplementation versus the ones who didn't have any supplementation at all. So as you can see here in this diagram, and these are the sections for the lesion tests. You can see that the lesion volume was much larger in the TBI mice that had no supplementation. The ones with the fruits and vegetables and the blend had much lower, and even the one that was just the fruits had a little bit more of an elevated level than the one that was just a blend of fruits and vegetables, which was more balanced. This is diet-induced reduction in neuroinflammation following TBI. So the levels were much higher in the TBI for inflammation, causing inflammation. The ones with the supplementation were much lower. Same thing for the capsaicin B and Bax protein levels as well. These were much lower for the GF2 and GF3. This one, they used the Western blot test, and as you can see, the ones with traumatic brain injury that did not have a supplemented diet are much darker than the rest of them for both proteins, and the protein levels are completely elevated in these ones that had the TBI without the supplementation, and low and next to none in the other ones. So in conclusion, it was determined that a prophylactic diet in mice decreased TBI when it was started before the injury. This study also showed that having a diet including foods containing antioxidants or natural anti-inflammatories can help with the prevention and treatment in the future. Also with Alzheimer's and dementia, this can also have an impact on these things as well. All of the mice in the experiment had the same amount of food intake throughout the entire experiment and had similar weight gain throughout it. And thank you for your time.